Hi, this is Chem 21, Chapter 2, Section 2.5. In this section, we're going to talk about significant figures and mathematical operations. First, we're going to talk, before we get to the math part, we're just going to do a couple slides about rounding, talk about how we want to round numbers. Rounding is the process of deleting unwanted or non-significant digits from calculated numbers. This is going to happen a lot when you use your calculator, because your calculator is going to give you a lot more sig figs than you actually need for your answers. So in order to round, if the first digit to be deleted is 4 or less, you're going to drop it and all the following digits. So for example, if your calculator gave you this answer, 5.83298, and you wanted to round your answer to 3 sig figs, you would just drop the 2 and everything that came after it. So if you wanted to round your answer to 3 sig figs, you would start at this 2, and since that's less than 4, you would drop that and everything that came after it, and your answer would be 5.83. If the first digit to be deleted is 5 or greater, then you would round up. So what would that look like? So for this number, 7.86541, since the first digit to be dropped is 5, then you would round this 6 up to 7. So 7.865 becomes 7.87 for 3 sig figs. So let's just practice. We're going to take the first 5 digits of pi, 3.1457. And for part A, you're going to round this number to 3 sig figs. And for part B, you're going to take this same number and round that to 2 sig figs. You're not going to round the answer in A to B. For A, you're going to round this number to 3 sig figs. And for part B, you're going to take this number and round it to 2. So hopefully you paused your recording and took a minute to work on that. So 3.1457, to round that to 3 sig figs, you would start at the 5 and drop those digits. And since 5 and up gets rounded up, this 4 would get rounded up to a 5, and your answer would be 3.15. To round 3.1457 to 2 sig figs, we would drop this 4 and everything that comes after it. And since 4 is less than 5, we would just drop all of these digits, and the answer would be 3.1. So mathematical operations with sig figs have 2 different sets of rules. To multiply and divide, your final answer, the number of significant figures in the answer, is the same as the number of significant figures in the measurement that contains the fewest sig figs. So when we take a number like 1.342 and multiply it times 5.5, this first number has 4 sig figs. The second number has 2. Our answer at our calculator has 4. But the answer has to have the same number of sig figs as the number with the fewest, which is 2. So we would round our number to 2 sig figs. 7.3, we would round it up to 7.4 because the number 8 is greater than 5. So 7.381 rounds up to 7.4. So let's do a couple more examples. If you want to go and get your calculator, it's important here to practice on your calculator and not your phone, because you're going to need to use your calculator for quizzes and exams. So if you put 6.0 divided by 2.00 into your calculator, it's just going to give you the number 3 for an answer. But your answer has to have the same number of sig figs as the number that has the fewest number that went into your calculation. This number has 2 because the trailing 0 is significant. This number has 3 because these 2 trailing zeros are significant. So that means your answer has to have 2 significant figures. So we have to add the 0.0 so that your answer will have the same number of sig figs as the number here that had the fewest. So you don't put 3 for your answer, you put 3.0. What if you have a multiplication and a division in the same question? Well, first, just put all the numbers into your calculator. 21.5 times 0.3, press the equal sign, and then divide by 1.88. So 21.5 times 0.3, press the equal sign, and then divide by 1.88. Now you get this crazy huge number. Or sorry, not a huge number, but a number with a lot of significant digits. So now you have to go back into your calculation and look at the number of sig figs for each number. This number has 3. This number has 2 because the trailing 0 is significant. This number has 3, 3, 3, and 2. So that means your final answer can only have 2 sig figs. So we're going to start with 3.4. We're going to drop all the numbers that come after that because this number is less than 5. So the answer is 3.4. So here's a practice problem for you. Pause your recording, put those numbers into your calculator. The number on your calculator is 8.631. This number has 4 sig figs. This number has 2. So your answer can only have 2. We're going to drop the 3 and everything that comes after it, and we're not going to round up. So those were the rules for multiplication and division. In addition and subtraction, the rules are different. The answer has no more precision than the least precise value. So we're not looking at numbers of sig figs here. We're looking at precision, how precise the numbers are. So this first number is precise to the thousandths place, tenths, hundredths, thousandths place. This number is precise to the hundredths place. So after we do our math, we correct it so that the answer is no more precise than the least precise value. The thousandths place is more precise than the hundredths place. This is more precise. We can see the number to more digits than this one. So the answer cannot be any more precise than the least precise value. Notice, in addition and subtraction, the answer doesn't have anything to do with the number of sig figs. It has to do with the precision. This is precise to the hundredths place, and this is precise to the hundredths place. So here's some more examples. 65.09 minus 3.0. 3.0 is precise to the tenths place. It is less precise than 65.09, which is more precise to the hundredths place. So our calculator gives us an answer of 62.09, but our answer has to be the same precision as the less precise value, the tenths place. So we round 62.09 to 62.1, because when we drop the 9, the 0 rounds up to 62.1. So add these numbers together and give the answer to the correct precision following the rules of addition and subtraction. So 82.409 is precise to the thousandths place. It is the more precise number. 22.0 is precise to the tenths place. It is the less precise value. So the calculator gives the answer of 104.409, but our answer can only be precise to the tenths place, 104.4. We drop these last 2 digits and we don't round. 220 is precise to the tens place because this 0 is not significant. Trailing zeros in a number with no decimal place are not significant. 22.0 is precise to the tenths place. It is the more precise value. Our calculator gives us an answer of 242.0, but our answer can only be precise to the same precision as the least precise value. Our answer is 240. The precision is in the tens place. This 0 is not significant because trailing zeros in a number with no decimal are not significant. Finally, what if we have a problem with addition and subtraction and multiplication and division? You will see examples of this when you calculate what is called percent error. Percent error involves subtracting an experimental value from an actual value. This example shows an actual value of 11.3 and an experimental value of 11.2. When we put these values into our calculator, 11.3 minus 11.2 divided by 11.3 times 100, we get an answer with a lot of sig figs. It turns out the answer can only have one sig fig because the subtraction part of this problem, 11.3 minus 11.2, only has one significant digit. The answer of 11.3 minus 11.2 is 0.1, which only has a single significant figure. And when we divide 0.1 by 11.3, it's one sig fig divided by 3 sig figs. So the answer can only have one sig fig. So when you do percent error problems, pay attention to the subtraction step when you calculate your number of sig figs. So here's all the rules on one page. For multiplication and division, the answer can have no more sig figs than the number with the fewest number. For addition and subtraction, the answer has to have the same precision as the least precise value. If you have any exact numbers in your calculation, they don't affect the sig figs at all because exact numbers don't have any sig figs associated with them in the first place. So for example, if you have a number like 9 pencils, it doesn't have sig figs associated with it. So if you have a measured value like 1.342 times 9 pencils, and you get this number out of your calculator, the answer would actually have the 4 sig figs from the measured value, not the 1 sig fig from the exact value. So exact values don't limit the number of sig figs. Only measured values have sig figs associated with them. Here's some links for sig fig practice. And remember, these links are always in the chapter module.